launched Sputnik 1, the first artificial satellite into Earth's orbit. This historic event marked the beginning of the space age, a time when the exploration of outer space became not just a possibility but a reality. As Sputnik traversed the heavens above, its iconic beeps were heard around the globe, signaling the dawn of a new era. The launch of Sputnik was a triumph of science and engineering, showcasing the potential of what humanity could achieve beyond the confines of our planet. However, it also ignited a fierce competition between the world's superpowers. The United States and the Soviet Union, already locked in the throes of the Cold War, now extended their rivalry into space, marking the start of the space race. This competition had profound implications, not only politically, but also technologically. The drive to surpass one another led to rapid advancements in rocket technology, materials science, and telecommunications. It compelled nations to invest heavily in education, particularly in the sciences, pushing a generation of young minds toward careers in engineering and physics. Moreover, the impact of Sputnik reached beyond the technological and political realms. It altered the course of international policy, leading to the establishment of treaties and collaborations focused on the peaceful exploration of space. For the public, the night sky no longer represented a distant, uncharted frontier, but a new world ripe for exploration and discovery. Sputnik's legacy is evident in every satellite that orbits our planet today, and in the international cooperation seen aboard endeavors like the International Space Station. It reshaped our culture, our technology, and our dreams. With a simple beep, Sputnik not only circled the Earth, but also permanently altered humanity's perspective on what was possible. From a dream to a televised spectacle, the moon was about to become a new frontier for humanity. The race to the moon, a breathtaking saga of ambition and ingenuity, began in an era where technology was just starting to stretch its wings toward the stars. Amidst the backdrop of the Cold War, two superpowers, the United States and the Soviet Union, embarked on a competitive quest that would etch their names into cosmic history. This intense competition was more than a mere show of technological prowess. It symbolized the zenith of human curiosity and determination. The Apollo program, spearheaded by NASA, became the focal point of this celestial rivalry. Among its crowning achievements was the Apollo 11 mission, a journey that remains one of the most audacious undertakings in the annals of human exploration. Apollo 11's preparation was a meticulous blend of science, engineering, and human courage. Astronauts Neil Armstrong, Buzz Aldrin, and Michael Collins were not merely passengers, but pioneers on a voyage beyond the confines of our world. As their spacecraft pierced through the veil of Earth's atmosphere, a breathless audience of millions around the globe watched with anticipation, their eyes glued to television screens. The climax of this mission was nothing short of cinematic. As the lunar module, Eagle, touched down on the Sea of Tranquility, an unprecedented wave of excitement swept across all continents. The moment Neil Armstrong descended the ladder, the air was thick with suspense and awe. His words, "That's one small step for man, one giant leap for mankind," resonated through the hearts and minds of the global audience, encapsulating the monumental nature of the achievement. This event did not just captivate viewers, it galvanized them. It sparked a surge in scientific enthusiasm and an insatiable curiosity about what lies beyond our celestial shores. The implications of the moon landing stretched far beyond the fields of astronomy and space technology, influencing culture, politics, and dreams of future generations. As Neil Armstrong set foot on lunar soil, he not only left a footprint but also a legacy of endless possibilities. Enter the shuttle era, where space became a destination, not just a dream. In 1981, the world witnessed the inaugural launch of the Space Shuttle Columbia, marking the beginning of a program that would redefine humanity's relationship with space. The Space Shuttle program, with its fleet of reusable orbiters, was not just about reaching for the stars, but making space travel a more frequent and versatile endeavor. Imagine a spacecraft that could launch like a rocket, orbit Earth, deploy satellites, and then land back on a runway like an airplane. This was the reality brought forth by the Space Shuttle. It was a blend of rocket and aircraft technology, a true marvel of engineering that opened up new possibilities for in-orbit activities including repairs, experiments, and construction. one of the most illustrious missions of the Space Shuttle was the deployment of the Hubble Space Telescope in 1990. Hubble's launch aboard Discovery revolutionized our understanding of the universe, peering deeper into space and time than ever before. Its stunning images of distant galaxies, nebulae, and stars continue to fascinate the world, providing invaluable data to astronomers. The shuttle era also played a crucial role in constructing one of humanity's most significant achievements in space, the International Space Station. Piece by piece, missions such as STS-88 began the intricate process of assembling the station in 1998. This monumental task showcased an unprecedented level of international cooperation in space, involving multiple countries and demonstrating the shuttle's unique capability to carry large payloads. Technologically, the shuttles were equipped with state-of-the-art systems that supported a wide range of scientific experiments. From studying the effects of low gravity on the human body to understanding environmental processes, the shuttle missions contributed profoundly to our knowledge across various scientific fields. The space shuttles bridged the gap between celestial dreams and human reach, turning astronauts into frequent flyers of the cosmos. Through 30 years of service, the shuttle program not only brought space closer to Earth, but also brought humanity closer together, under the shared canopy of the stars. Mars, the red planet that has always sparked human curiosity, now beckons as the next frontier. Our journey to Mars began with the audacious Pathfinder mission, which landed the first rover, Sojourner, on the Martian soil in 1997. This small but mighty robot paved the way for all that followed, testing technologies and exploring the landscape, setting the stage for its successors. Then came Spirit and Opportunity. Twin rovers launched in 2003. These robotic explorers were tasked with a mission to search for evidence of past water activity on Mars. They did not disappoint. Spirit uncovered hints of ancient hot springs and silica-rich soil, suggesting that water once flowed there, potentially supporting life. On the other side of the planet, Opportunity outdid itself, operating for almost 15 years and confirming that Mars had areas soaked with water in the past. Curiosity, which landed in 2012, took things a step further. Armed with a lab full of scientific instruments, this car-sized rover analyzed rocks and soil to study Mars's habitability. It found complex organic molecules and fluctuating methane levels in the atmosphere, pushing our understanding of the planet's potential to host life. These missions collectively have painted a picture of Mars not as a static, barren landscape, but as a world with a dynamic history, including dramatic volcanic activity and shifting environmental conditions. Each discovery has been a building block, showing us that Mars once had conditions suitable for life as we know it. Now, as we continue to receive data from these missions, the dream of human footsteps on Martian soil grows ever more tangible. Agencies worldwide are drawing up plans, and the technology for a manned mission is in the advanced stages of development. Each rover's wheel tracks on Mars weave a path not just across a planet, but towards a future where humans might one day walk these paths too. As we stand on the shoulders of the colossal achievements of the past, we gaze into a future filled with even grander cosmic voyages. The next chapters in space exploration promise to redefine the boundaries of human achievement and scientific discovery. In the near future, an array of missions are set to launch, spearheaded not only by traditional space agencies like NASA and ESA, but also by a vibrant constellation of private companies. SpaceX, Blue Origin, and newer entrants from around the globe are propelling us into a new era where space travel becomes more accessible and frequent. These collaborations are not just expanding our capabilities, but are also fostering a global approach to space exploration. As we venture further, technologies once penned in the realm of science fiction begin to stir towards reality. Imagine space elevators, towering structures reaching into the heavens, reducing the cost and environmental impact of launching materials into orbit. Consider the prospects of interstellar travel. Projects like Breakthrough Starshot hint at the future, where we might send lightweight probes to nearby star systems, propelled by laser beams and sailing on light. The thought of human settlements on other celestial bodies transforms from a daydream into a detailed plan. The moon, our eternally enigmatic neighbor, is eyed not just for visits but for prolonged human presence. Visionaries chart out how life on Mars could look, not just surviving but thriving, creating self-sustaining colonies that could one day blossom into vibrant communities. These advancements prompt us to ponder profound questions. What does it mean for humanity to become a multi-planetary species? How will our social, ethical, and environmental responsibilities evolve as we spread through the cosmos? The implications are as vast as space itself, urging us to consider not just the technological but the philosophical dimensions of our expansion across the universe. The cosmos